There are objects in the universe so large, so extreme, that they seem impossible. Things so big that our minds struggle to understand their scale. Stars larger than entire planetary systems. Stars so vast that if they replaced our sun, the planets themselves would disappear inside them. Deep inside our Milky Way lies one of the biggest stars ever discovered. A star so large that even astronomers are not completely sure how something like it can form. Its name is Stephenson 218, and it may be one of the largest stars the universe has ever created. Stephenson 218 lies deep inside our galaxy, hidden behind thick clouds of dust near the constellation Scutum. This region of the Milky Way is difficult to observe. Visible light cannot travel far through the dust, so for many years, astronomers could not see what was there. But with infrared telescopes, scientists began to look deeper. In the 1990s, astronomers studying this region found a cluster of massive stars. The cluster became known as Stephenson 2. Among them was one star that stood out from the rest. At first, it did not seem extraordinary, just another distant red star in a crowded part of the galaxy. But as measurements improved, astronomers realized this star was far larger than they expected, much larger than most stars we know, large enough to challenge the limits of how big a star can be. That star became known as Stephenson 218. Stephenson 218 is what astronomers call a red supergiant. These are among the largest stars that can exist. They form when massive stars begin to run out of fuel. As the core changes, the outer layers expand. The star grows larger until it becomes enormous. Red supergiants are not rare, but the largest ones exist only for a short time. They are unstable, swollen, barely held together by the balance of gravity and pressure. Their outer layers are so far from the core that they are only weakly bound. In some cases, the surface of the star can take years just to complete a single rotation. These are not stars in the way we imagine them. They are closer to giant spheres of gas, barely holding their shape. Red supergiants are cooler than smaller stars, which gives them their deep red color. But even though they are cooler, they shine with incredible brightness because of their size. Some red supergiants are hundreds of times larger than the Sun. A few are more than 1,000 times larger. But Stephenson 218 is in another category entirely, because this star is not just large. It may be one of the biggest stars ever discovered. Stephenson 218 is estimated to be more than 2,000 times the radius of the Sun. To understand what that means, we have to compare it to our own solar system. If Stephenson 218 replaced the Sun, its surface would stretch far beyond Earth, past Mars, past Jupiter, past Saturn. Some estimates suggest it could reach almost to the orbit of Uranus. Everything inside that distance would be inside the star. Planets, asteroids, comets, gone. The Sun, which already seems enormous to us, would look tiny next to Stephenson 218. More than 1 billion suns could fit inside its volume. Light itself would take hours to travel across the star. If you could fly a spacecraft around its surface at the speed of a jet airliner, it would take months just to go once around. From far away, it would not even look like a star. It would look like a glowing world, larger than the orbit of planets. And yet, this enormous object is still only a single star. Even the largest stars we know rarely reach this size, and that is what makes Stephenson 218 so strange, because stars are not supposed to grow this large. At some point, something should stop them. Yet this one kept expanding until it became one of the biggest stars ever found. And what makes it even stranger is that stars this large should be extremely rare. The larger a star becomes, the harder it is for gravity to keep it together. Most stars never reach this size. Stephenson 218 somehow did. Stars are held together by a balance. Gravity pulls inward. Pressure from nuclear fusion pushes outward. As long as these forces are equal, the star remains stable. But the larger a star becomes, the harder it is to keep that balance. When a star grows too large, its outer layers become unstable. Gas begins to escape. The outer layers are pushed outward by intense radiation. At the same time, gravity struggles to hold the star together. This creates a constant battle between collapse and expansion. For most stars, this battle ends early. They lose mass before they can grow too large. But Stephenson 218 seems to have reached a size close to the theoretical limit, which is why astronomers still debate exactly how it formed. It may have formed from an unusually massive cloud of gas, it may have merged with another star, or it may be losing mass right now, slowly shrinking after reaching an even larger size. Red supergiants are difficult to measure, and their outer layers are not solid. They expand and contract, changing over time. But even with uncertainty, it is still one of the biggest stars ever observed, and stars this large cannot live long. Massive stars live fast and die young. They burn through their fuel much faster than smaller stars. While the Sun may live for billions of years, a star like Stephenson 218 will survive only a fraction of that time. As it continues to evolve, its core will become unstable. Fusion will stop. Gravity will take over, and the star will collapse. When that happens, the result will be violent. The collapse of the core happens in seconds, but the explosion that follows can release more energy than the Sun will produce in its entire lifetime. For a brief moment, the dying star can shine brighter than all the stars in its galaxy combined. The shock wave spreads outward, tearing the star apart. Everything it once was is thrown into space. The outer layers of the star will be blown away, creating clouds of gas that may one day form new stars. These clouds carry the elements created inside the star: carbon, oxygen, iron, the same elements that make planets, oceans, and life itself. At the center, the core will remain. Depending on its mass, it could become a neutron star, or even a black hole. One of the largest stars ever known, ending its life as one of the most extreme objects in the universe. The universe is full of giants. Black holes larger than galaxies, stars bigger than solar systems, structures stretching across millions of light years. But every time we think we have found the limit, we discover something bigger. Stephenson 218 is one of those discoveries, a star so large that it should barely be possible. A reminder that the universe still has extremes we do not fully understand. And somewhere out there may be stars even larger than this one. Join us next time as we explore more mysteries of the universe.